Today we are going to see electricity passed through. This much time, cell was producing electricity. Now, electricity. Now we are going to pass electricity through cells. Passed through. Electricity. We are going to pass electricity. Of course, when we pass electricity, the cell will be giving a resistance. It will be applying a resistance. Any material you pass electricity, that material will be giving a resistance. Some materials do not give that much resistance. We call them conductors. If they give you lots of resistance, then we say bad conductor or then inspector. Now, through the cells, cell means solution in which the solute, the electrolyte is dissolved. Electrolyte in the sense when dissolved in water changes into positive and negative ions. Only those solutions can carry electricity. Sugar solution cannot conduct electricity because sugar molecules do not separate into plus and minus signs, positive and negative ions. But salt, NaCl, electrolyte, that will be changing into Na plus and Cl minus, CaCl2, Cl2 plus Cl minus, MgCl2, Mg2 plus Cl minus, AlCl3, Al3 plus Cl minus. So these are the electrolytes, different electrolytes when dissolved in water will be conducting electricity. Sucrose, ordinary sugar, your glucose or urea, they do not conduct electricity and dissolved in water because they cannot get converted into, they cannot get be broken into ions. So with cells means there is an electrolyte dissolved in water or it is an electrolytic solution. How can you pass electricity through cells? Of course, conductor. But what is the resistance offered by the cell or that electrolytic solution in the circuit? We are going to. We don't want actually resistance because we hate resistance. We need good conductors. Resistance always that reduces the power or energy. So we are considering the cells which can conduct electricity. Call it as a conductor. Cells are conducting electricity due to that electrolyte which is broken into positive and negative ions. These ions can carry. But how can you connect a cell into the circuit? In physics, it is very easy to connect a wire. You must have seen the wire, copper wire, which is wound round with that thread. You remove that thread and you connect it from. It is very easy for easy in physics to connect these types of wires. But how can you connect a cell, a solution? How can you connect a solution, an electrolytic solution? That is not easy. To what position you connect? No two ends. So for that we take a conductivity cell. Conductivity cell means it is a glass tube. It is a glass tube with an opening. In this, we fill that sodium chloride solution or potassium chloride solution. Here, this is see here one disc type connector. Disc, for example, one platinum metal in the disc shape. A disc shape like this. This is kept over here and this is kept over here. Like this, you are seeing the vertical way. You are seeing it is not like this kept, it is like this kept. instead of connecting the wire, we have to connect a cell. It means a solution. The solution is taken in this glass tube called conductivity cell. Conductivity cell. In physics, we are connecting a wire, this and this connected, this and this connected. But in chemistry, this electrolytic solution, the solution cannot be connected. So, a fused wire with the glass that is taken, it is fused very well sealed. Solution will not go out. There is an opening, you can open this lid and you can fill the solution. After using, open the lid and take out the solution, you can fill another solution of different concentration. So, if it is a wire, as in the case of physics, and you pass electricity through this wire offers resistance. What is that resistance? That resistance is directly proportional to length of the wire. When the length of the wire increases, resistance of this material, of this wire increases, and R is inversely proportional to 1 by A as the area of cross section. When the area of cross section increases, resistance decreases. So resistance is inversely proportional to area of cross section. Or you can write as R is proportional to N by A. R is directly proportional to the length and R is inversely proportional to A. Now this is our conductor. R is directly proportional to F, length of this conductivity cell or length of the solution. And R is inversely proportional to the area of cross section. R is equal to a constant rho into L by A. This rho is called resistivity. The unit of R is ohm, length is centimeter per meter, A is centimeter square per meter square. Here, R is equal to rho. This is the resistivity. Rho is the resistivity or specific resistance or specific resistance. What is the rho is equal to RA upon F. What will means unit? Unit is ohm. Meter square upon meter means ohm meter. Yeah, ohm centimeter. R is the resistance. You can measure using an experiment. Resistance you can measure using heats and bridge. Its opposite, that is conductance. Conductance cannot be measured. So to know the conductance of a material, find out the resistance and take the inverse. Take the inverse of the resistance, that is conductance, which is denoted by the letter. We don't have that much use for this G. Resistance is O, its unit is O. Conductance Rho, MH, opposite. Or ohm in, that is also conductance. will you determine or measure the resistance of a conductivity cell? Before that, let's first go to how to find out the resistance of a wire. For that, the circuit diagram for resistance bridge. We introduce one resistance R1 here. We introduce this is known resistance. Known resistance. We introduce another resistance R3 here. One R4 here. Thus we introduce a resistance. And this resistance, this is unknown resistance, that is R1, R2, R3, R. And this is connected through a galvanometer. Galvanometer shows whether any electricity is flowing through this. And one battery and this galvanometer, when it reads 0, this is balancing, when it reads 0, then R1, R4 is equal to R2, R3. When this reads 0, when we say this distance bridge is balanced, this is like balancing method. So, when this reads 0, accordingly you can add resistance to make it read 0. To get a reading 0 in this galvanometer, you can adjust R1, R3 and R4. R2, this is the unknown resistance. This is the unknown resistance. This is known resistance. Known resistance. So when it is balanced, this it is in your hand, this it is in your hand, this it is in your hand. This is the unknown. So R1, R4 is equal to R2, R3, R1, R. So this is the unknown resistance R2. So unknown resistance UK, that is R2 is equal to R1, R4, R3. This is how we find out the unknown resistance. Now, in physics, this is a wire, but in chemistry, this is not the wire. It is a solution, electrolytic solution. Electrolytic solution is taken in a conductivity cell. The conductivity cell with that lid and all, you fill this, open the lid and fill this conductivity cell, and the conductivity cell is connected in the circuit. Again, you balance this thing. After fitting the cell, you change R1, R3, R4 so that it reads 0. This is when it is balanced. You can calculate R2 is equal to R1, R4 upon R3. That is how we find the resistance of this solution, electrolytic solution. This has got a length that is F, and area of cross section, that is area of cross section, is this area of cross section of that platinum electrode, that disc. So the solution is what that is confined between these two electrodes. You have to consider that column of that solution, electrolytic solution, confined between these two electrodes, platinum discs, platinum electrodes. Okay, you have found out this resistance unknown resistance. Our aim is to find out the conductivity. For that, what is conductivity? Conductivity. Resistivity, you know that is rho is equal to RA upon L. Rho is equal to RA upon L. This is the resistivity. Inverse of that resistivity is conductivity. What is conductivity? 1 by rho is equal to 1 by R into L by A. What is 1 by rho? That is the conductivity. The inverse of resistivity is conductivity. Inverse of resistance is conductance. Right? This is derived as kappa K. 1 by rho is equal to, that is kappa K. It is written like this, kappa, some bending on the top and bottom, that is kappa. Kappa is equal to 1 by R into L by A, or RK is equal to L by A. For this special conductivity cell, for this glass tube, L is constant, and area of cross-section of that platinum electron, what is kept inside, that is also constant. So, L and A both are constant. A constant divided by another constant is another constant. So, we call it as RK is equal to G star. RK is equal to G star. G star is called the cell constant. It is given by L by A. What is the unit of cell constant? Centimeter upon centimeter square, that is centimeter inverse, or meter upon meter square, that is meter inverse. So RK is equal to G star. What is K? K is the conductivity. That is our final point. We are going to raise that term conductivity. Conductivity kappa of an electrolytic solution you have to find out. Conductivity kappa of an electrolytic solution you have to find out. So to find out this conductivity kappa, two things you want to know, that is, one is resistance and one is the cell constant. What is the resistance? How can you find out the resistance of the solution? Of course, you connect it in the resistance switch. You can find out the resistance by using what? By using, that is R1, R4 upon R3. That is how you are going to get the resistance. So resistance is available here. Okay. Kappa you will be finding out. So you need what? G star. That is L by L. Of course, you can measure from this into that. But A cannot measure A because that is kept fixed. That is fixed inside that glass tube. You cannot break the glass tube and find out that A. So you are going to do an indirect method to find out this G star. L, of course, you can find out by measure. L value you can find out, but A, area of cross section, it is not possible to find out the area of cross section. So you have to find this L by A. So now our first duty is to find out G star, that is L by A. How to find out this L by A? For that, we will be using this equation first by using a known K. By using a known K, solution will be supplied to you. This known K will be given to you. Yes, this known K is available. That K will be given in the numerical or by your teacher when you are doing the experiment in the laboratory. Your teacher will give you a known K, a solution whose K is given supplied known. So you will be substituting that K over here, and that solution's resistance you will be finding out using these two steps. Then you can find out G star. Using this G star, you will be finding out The unknown solution K is responsible for a particular cell, particular glass. This is the unknown K. So twice we'll be finding out the resistance. First we have to find out these two steps are there for this experiment. First we have to find out the G star. To find out the G star, K will be given. K of a particular solution will be given. That solution you fill in this conductivity cell. Fill that first solution to kappa is known. Kappa is supplied in the membrane. Using that kappa and finding out its R by fitting in this fill that solution. Whose kappa is given, that solution you fill, you make that solution, and that solution you fill in the. For example, 0.1 molar KCl solution. 0.1 molar KCl solutions. Kappa is given as 0.1 molar KCl solution. Kappa is given as kappa is equal to 1.29. 0.0129 as centimeter equals or 1.29 as meter equals. Either you can take the value in centimeter inverse or you can take the value in meter inverse. This will be given in the numerical. So from the numerical, from one box, some numerical will be given. In that 0.1 molar solutions, 0.1 molar solutions, kappa will be given either in centimeter inverse or in meter inverse, as centimeter inverse or as meter inverse. You prepare that solution and fill 0.1 molar KCl solution. You prepare and fill in this conductivity cell. Find out its resistance. So kappa is given. This kappa is given. I'm going to substitute. Okay, this is equation 1, equation 2. Resistance I have to find out R is equal to kappa. What is kappa? For centimeter inverse, maximum will be using centimeter inverse only. That is 0.0129 is equal to G star. First equation is used to find out G star. So to find the G star, now we need R. How will you find out R? You prepare the solution. Which solution? 0.1 molar solution. You prepare the 0.1 molar solution. To prepare 1 molar solution, 74.5 grams of KCl is to be dissolved in a solution and make the solution to 1 liter. Shake it well. For uniform consumption, that solution will be having 1 molar. But to make 0.1 molar, then 7.45 gram of KCl is to be dissolved to make the solution of 1 liter. That solution you fill in this and you find out the R. Using this division spread, you find out this R. So this R into this will give you G star. Keep that G star for this equation number 2. Keep that G star is constant for this equation number 2. And the unknown solution is given to you by your teacher. So that unknown solution, when you remove the solution and you fill that unknown solution, and again you find out this resistance by resistance bridge. Now G star is available. You can find out this. K. So write one question. I'm giving that question in 3 parts. First 2 parts. First part is to find out G star, and the second part is to find out kappa. There is one third part is also there that we have to do after learning molar conductivity. Question. Resistance of a conductivity cell. The resistance of a conductivity cell filled with 0.1 molar KCl solution is 0.1 molar KCl solution is 100 ohm. 100 ohm. What is the cell constant? What is the cell constant? This is first part. Second part. If the resistance of the same cell, when filled with 0.02 molar KCl solution. See, now the solution concentration is changed. 0.0, this is another solution. 0.02 molar means this is another solution. First solution was this. If the resistance of the same cell, when filled with 0.02 molar KCl solution is 520 ohm, 520 ohm, calculate its conductivity. So first thing we have to find out G star. G star के लिए we'll be using R is equal to G star. Right? R is given 100 ohm. K is given. What is K? K value 0.1 molar. That is 0.1 molar, 0.0129. That will be given to the numerator. Or just now I have written. So that is 0.0129 S centimeter inverse equal to S means that is 1 by 4. So G star you will be getting in centimeter inverse. That is 1.29. This calculate that you will be getting 1.29 centimeter inverse. That 1.29 centimeter inverse you will be using in the second equation again R is equal to G star. So instead of that G star, now we are going to write 1.29 centimeter inverse. Now resistance of this solution, we have again found out that is 520 ohm into copper. Right? 520 ohm into copper. Now you can find out copper is equal to 1.29 centimeter inverse upon 520 ohm. So ohm inverse centimeter inverse will be the ohm inverse means S. Ohm inverse means S. So ohm inverse centimeter inverse. You can write like that, or you can write S centimeter inverse. So you will be getting this as S centimeter. That's about this conductivity. One more part is that molar conductivity. That molar conductivity, that is the next topic that we will be doing in the next.